Lecture 7 for today, which is June 10th. June 10th, yeah. All right, so today we're going to talk about solve inequalities. So it's different from equalities, but it's only different in one thing. So everything else is the same as when solving equality. Let's go over solving equality first. Let's see if we have 2x minus 5 equals to 3. Right? What do? We would move negative 5 to the other side. It become positive 5, become plus 5. Right? Then we have 2x equals to 3 plus 5, which is 8. Then we divide by 2 on both sides. 8 divided by 2 get 4. So we will have only one solution for equality. But for inequality, we will get infinitely many solutions. Let's see the difference. But the process is similar. So negative 5 will move to the other side. It becomes positive 5 on the other side. So get 3 plus 5. Well, 3 plus 5 is 8, which is rewrite the inequality sign. This inequality means greater than or equal to. Greater than or equal to. And we have only 2x now. Because of negative 5, we moved it to the other side, become positive 5. Now we divide by 2 on both sides. So divide by 2, we get an x greater than or equal to 8 divided by 2, which is a 4. Well, let's draw on number line. Right, so this is our real number line. 0 sits in the middle. On the left-hand side, negative. On the right-hand side, positive numbers. So we want to mark number 4. So 4, somewhere here. Then all the numbers greater than or equal to 4. Because we have equal sign equal to 4, so we'll make a solid dot. Greater than means we go to the right, right? Who's waiting on the very right-hand side? Positive infinity. So how many numbers in between 4 and the positive infinity? Like infinitely many. So the solutions for this are infinitely many numbers. So that's the difference between equality. Equality we see here, there's only one solution. Right? X can only be 4. But here for inequality, here the solution is all the numbers, as long as it's greater than 4 or equal to 4. So start with the 4 and including 4. 4 and all the numbers greater than 4. So this is the inequality. So we have infinitely many solutions. So far we see everything is the same. The process of solving inequality is the same as solving equality. But let's see the second one. Second one will show some difference between solving equality and inequality. So let's move negative 5 to the other side. Move negative 5 to the other side, become positive 5 on the other side. Then at the same time, we'll move positive 6x to the other side, becomes negative. Well, this 3x is positive, so we just carry on. Now, 6x on the right-hand side now becomes a negative 6x on the left-hand side. We have this is called less than sign. So the left-hand side less than the right-hand side. 7 plus 5 is 12. Well, 3x minus 6x, that's negative 3x, right? Then less than 12. Now we want to get 1x, so we need to divide by negative 3x. Let me change my color. We want to divide both sides by negative 3. So negative 3x divided by negative 3, we get a 1x, right? We could write a 1x, but a lot of times we just don't bother to write this 1. This is by default. If it's x, means if it's only x, that means 1x. That means x is by 1 and divided by 1. Okay, all those by default. So x is 1x is x raised by the first power is x divided by 1. All right, so x now, because we divide by a negative number, we need to flip this inequality sign. Before was less than, now becomes greater than. 12 divided by -3, that's -4. That's the only difference between solving equality and inequality. So when we divide by a negative number on the left-hand side or multiply by a negative number on the left-hand side or on the right-hand side, we flip the sign, okay? The less than sign becomes greater than sign. So that's the only difference. All right. And yeah, so let's see C. Let me clean up a little bit. I need more space. So C, we see the denominators. We have rational expressions, right? The denominator, we have 4, we have 2, we have 8. So the least common denominator will be 8, right? Because 8 is a multiple of 4, is a multiple of 2. So let's multiply everyone with 8. X plus 1 divided by 4 multiplied by 8, we get 2 times x plus 1, right? Because 8 divided by 4, that's 2. 2, we need to multiply by the numerator. Then the greater sign, we just carry on. Now 8 divided by this 2, that's 4. So we have 4 times 2x minus 1. Then plus 3 divided by 8. Then multiply by 8. 8 divided by 8 is 1. 3 times 1 is just 3. So that's how we got rid of the denominators, by multiplying that least common denominator. Now the rest was just distribute 2. Distribute 4. Okay, let me do here. 2 times x, 2x. 2 times 1, 2. Greater than 4 times 2x, 8x. 4 times -1, -4. Then plus 3. Combine like terms, -4 plus 3, -1. So we have ax minus 1 on the right-hand side, or 2x plus 2 on the left-hand side. Now move positive 2 to the other side, becomes negative. Move ax to the left-hand side, becomes negative. -1 minus 2, -3. 2x minus ax, just think 2 minus 8, that's -6x. Greater than -3. Now divide both sides by -6. -6 divided by -6 is 1. 1x, just write as 1. Now, because we divided by negative number, we flip this sign. The sign was greater than, now change to be less than. -3 divided by -6, that's half. So the solution is all the numbers less than half. Now let's see D. D, let's move 5 to the other side, becomes -5. Let's move x to the left-hand side, becomes negative. -2 minus 5, -7. X minus x, 0. So we get 0 less than or equal to -7. Well, this is a true statement, right? 0 indeed is less than -7. No, that's no, I don't know. 0 is not less than -7. 0 is bigger than -7. So this is a false statement. So this statement is false. What does this mean to us? It means no solution. No such number to make no solution. Okay. No any number. X cannot be any number to make this inequality true. Because x equals x is 5 less than or equal to -2, which is impossible. 0 is less than or equal to -7, which is impossible. 0 is bigger than -7. So no solution for this. On the other side, if we had another one, let me just make an example. If in the end, maybe you get something like 0 greater than or equal to -7. This is a true statement because 0 is indeed greater than -7. If it's a true statement, that means x can be all real numbers. Okay. So in this case, it's a true statement, true inequality. That means x can be all real numbers. All right. Now let's see. Oops. Too quick. Let's see. 2. Okay, 2 ask us to solve, then put it in interval notation. So this is one more step. Okay. Put in interval notation. So this is with and. So this is system now with and. So let's solve for the first one. We'll move 1 to the other side, becomes 6 minus 1. So that becomes x less than 6 minus 1, which is just 5. So this is a solution for the first inequality. For the second inequality, we move positive 3 to the other side, becomes negative. So this becomes x greater than or equal to 2 minus 3, negative 1. And this is the end. End means we're looking for the intersection of those two solutions. If it's difficult to tell, we can always graph. Put a 0 in the middle, we need a negative 1, more than 5, probably somewhere here. The first solution is x less than 5, but not including 5. Make an open circle. Less than to the left until negative infinity. And this one, x greater than or equal to negative 1. With, let me use different color. So mark negative 1. Because we have equal sign here also, so we mark a solid dot. Solid, because negative 1 is in the solution. Greater than means we'll go to the right. We'll go to positive infinity. We're looking for and, looking for the intersection. Intersection means the solution belongs to both. So we see right here, okay? This part is a solution for the first one, is also a solution for the second one. So how do we represent the interval notation? We say started with a negative 1, including negative 1, bracket. The ends at 5, not including 5, close parenthesis. So this is the interval notation. Let's see the second one. Second one, we see one inequality, but with 2 inequality signs. So what does this mean? This means this actually is made of 2. One is negative 3 less than or equal to 2x minus 5. And this means then and 2x minus 5 less than 3. Because we see 2x minus 5, 2x minus 5, that's why we can put them together. We can put them together. So how do we solve this? We can solve this way by break up into 2. Then the rest is the same as 8. Or let's do something different. Or I can do this simultaneously. So first, I'm going to add 5 so we have 3 sides. So we have left-hand side, we have middle, we have right-hand side. Because I have negative 5 here, so I'm going to add 5. Why I want to do this? Because when I add 5, that becomes 0. But I can only not add it to the middle. I have to add it to the right. I have to add it to the left. Right? Positive 5 minus 3, left-hand side, I got 2. Then the middle part, negative 5 plus 5 is 0. So I'm left with 2x. Then less than 3 plus 5, which is 8. Okay. So I add 5 simultaneously on 3 sides. Now I see the middle one, I have 2x. I want to get a 1x. So I divide by 2. I need to divide by 2 for 3 sides. Divide by 2 for the left-hand side, divide by 2 in the middle, divide by 2 on the right-hand side. So I do things simultaneously for 3 sides. Now 2 divided by 2, I get 1. 2x divided by 2, I get an x. 8 divided by 2, I get a 4. Okay? So this is set notation, a set builder notation. So how do I represent it with the interval notation? Because I'm asked to do so. Again, 1 is included in the set of the solution. So bracket starting with 1, and that's 4, but not including 4. Right. All the numbers in between 1 and 4, including 1, not including 4. Let's see 3. Also, we need to represent the interval notation, but this time is or. Before was and. And this also means and. When we write them together, also means and. Now we want to or. Remember, or is a unit. Okay? Or is a unit. As long as the solution one of it, we just combine all the solutions. So let's solve for this one. -5 on both sides. So we get x less than or equal to -2 minus 5, -7. Second one, -5 on both sides. We'll move positive 5 to the other side, become negative. X greater than or equal to 2 minus 5, which is -3. If it's not obvious again, let's draw the picture. Because both numbers are negative, so we write a 0 a little bit to the right-hand side. Let's say this is -3. Then this probably like a -7. X less than or equal to -7. Including -7, so we draw solid dot. Less than, go to the left. Now let's draw the second one with a different color. Let's draw x greater than or equal to -3, including -3. Make a solid dot. Greater than, go to the right-hand side. Positive infinity waiting on the very end. Now, because it's an or, if we're looking for and, there's nothing in the nothing overlapping in these two, right? If we're looking for and intersection, that would be the empty set, which we talked about the last class. You can use this notation. You make a like an O, you slash through this O, or you could use empty braces to represent. There's no solution. Okay, but here we're looking for or. Or means this solution set plus this solution set. So we use the sign unit to represent. So use the interval notation to represent this one. We start from left-hand side, which is -infinity, up to -7, including -7 with bracket. Unit means combine, starting from -3, including -3, up to positive infinity, right? So this is because of this or. Okay, so we unit these two solution sets. Now let's see B. We do the same thing. -5, then -4. You can think as moving around. 3x minus 4x, -1x, greater than -5 minus 1, -6. We need to divide by or multiply by -1. Remember, when we divide by or multiply by negative number, we flip the sign. Now the greater than sign becomes less than. -6 divided by -1, +6, so x less than 6. So that's the first one. Now let's use blue color to the second one. +4 on both sides, -2x on both sides, x minus 2x, -1x, less than 6 plus 4, 10, multiply by -1 or divide by -1 on both sides. Flip the sign, less than now becomes greater than. 10 divided by -1 or multiply by -1 is -10. So we have these two solutions. Now we're looking at or. Let's draw the graph again. We have 0. Let's see, this is 6. This is a -10. X less than 6, not including 6. Open circle. Less than, go to the left-hand side, -infinity. This one, x greater than -10, not including -10, open circle. Greater than, go to the right, positive infinity. If we were looking for intersection, we would see that goes from -10 to 6, right? Not including -10, not including 6. But looking for or, we unit. If we unit those two sets of solutions, we see that's all real numbers. So for this one is negative infinity up to positive infinity. Okay, all real numbers. Let's see for solving absolute value equation. Remember the definition for absolute value equation? Absolute value of x equals to x if x is a non-negative, right? If it's negative, so we put negative, negative. The double negation makes positive. Give an example, if x is a 2, the answer is just 2, but just x, just 2 itself, because 2 is positive number. But if we have negative 2, absolute value will become positive 2. How? We'll put a negative sign in front of a negative 2. Because negative, negative become positive. Right? So that's this one. So that means this value can be positive or can be negative. So for A, that means 3x minus 2 can be positive 5, or 3x minus 2 can be negative 5. So we have two cases to consider. First case is positive 5. Second case is negative 5. Then we just solve. We add 2 on both sides. So 3x equals to 7 divided by 3. X equals 7 over 3. Right? First solution, x equals 7 over 3. Well, second one, plus 2 on both sides. 3x equals to negative 5 plus 2, negative 3. Divided by 3, x equals to negative 1. So we have two solutions. Okay. Now let's see B. B, we have this absolute value of y plus 2, but we have this 2 in front. 2 multiplied by this equals 8. So we want to get rid of this 2. How do we get rid of this 2? We divide by 2. Right? 2 divided by 2 becomes 1. So we have 1 times y plus 2, absolute value of it. Then 8 divided by 2, we get a 4. Then the rest is the same. We divide into two cases. So inside, y plus 2 can be positive 4, or inside y plus 2 can be negative 4. Then subtract 2. So y equals to 2 is one solution. Subtract 2. Y equals to negative 4 minus 2, negative 6. Two solutions. Okay, two solutions. Let's solve absolute value equation. Now let's see 5. Absolute value inequality. Well, this is less than sign. Let's just make a picture to think. So let's see 0 is here, and 3 is here, negative 3 is here. And this one, absolute value is less than 3, right? Which means the distance of this from 0 is less than 3. So we see it has to be in between of those two, right? But not because no equal sign is an open circle, not including those two. So this question takes some thoughts, because the absolute value is less than 3. If this inside were negative, that means it has to be between less than 0 but greater than negative 3. If inside is positive, that means it has to be less than positive 3, right? So we need to break into two cases. So the first case is inside x plus 4 is greater than negative 3, right? It has to be in between somewhere here. Second, x plus 4 is less than positive 3, right? Means somewhere here. So then solve. Subtract 4 on both sides. So that's x greater than negative 7. Subtract 4 on both sides. That's x less than -1. Okay, so we have two solution sets. Of course, also we want to use interval notation. So one solution set is this, x greater than -7, which means we're starting from -7, but not including -7. Greater than goes to positive infinity. X less than -1, starting from -infinity up to -1, not including -1. To the solution, because we have these two sets, so just uniting those two. Because this one is a solution, this one is also a solution. Both solutions work for this. So we unite these two. Similarly for B, first case, oh, it's different. Okay, this is greater than or equal to 6. So let's draw another picture. Let me use red color. So we need to mark +6 and -6. You see, it's greater than now. Think about this one. If I have -7, right, the absolute value will be greater than or equal to +6. But if I had a -5, the value will be 5. That would be less than or equal to 6. So which means, the first case means 2x minus 3 either less than or equal to 6. Or second, if it were positive, it has to be greater than or equal to 6. So if inside positive, it has to be a number bigger than or equal to 6. If inside or negative, it has to be, oh, I'm missing -6. No, negative is too small. The inside has to be a negative number, has to be less than or equal to -6. So just compare those two. And solve at 3 on both sides. -6 plus 3, -3. This side on the left is 2x divided by 2. So get x less than or equal to -3 over 2. So this is one solution set. And this one, add 3 on both sides. 2x greater than or equal to 9. Then x greater than or equal to 9 over 2. Right? Use the interval notation. X less than or equal to, starting from -infinity up to -3 over 2 with bracket. Union x greater than or equal to 9 over 2. Bracket starting from 9 over 2 up to positive infinity. So all those numbers in this one works for this inequality. This is 6. 6, we want to graph. We want to graph this inequality, So how do we graph? First, we want to simplify. We want to solve for y. So we would divide by 3 for everyone. When we do that, we get a y greater than, well, this x divided by 3 is 1/3 of x. Okay? Then minus 3 divided by 3, which is 1. So get this. So first we want to graph y equals to 1/3 of x minus 1. Let's graph this. How do we graph? So we use 2 points, x-intercept and y-intercept, right? So if x is 0, we get a y equals -1. So we get this point. If x equals to 3, 3 times 1/3 is 1, 1 minus 1 is 0. Right? So get 3, 0. You get this point. Now, with 2 points, we can graph it. We can graph this line. But we are going to graph with dotted line. We're not going to graph with solid line. We're going to graph like this. Dotted line. Why? Because we want to make a difference with the equal sign. When we graph y greater than or equal to something, then we'll make a solid line. This one only greater than signs will make a dotted line. Because this is a y greater than this, that means all the value of y is above this line. So the solution is all those points all those points with X value, Y value will work for the inequality. Right? We see this is not a one-dimension solution anymore. This is two-dimension solutions. All those points, the X value and Y value, will satisfy this inequality. Right? So we shaded this whole area. Now let's see B. B also, we want to solve for Y. So what do? First, we move positive 4x to the other side. It becomes negative. Then we divide by -2 for everyone on both sides. Right, -2y divided by -2, we get a positive y. Because we divide by a negative number, we gotta flip this sign. Greater than now becomes less than. 6 divided by -2, -3. -4x divided by -2 become positive 2x. Right, we can rewrite as y less than 2x minus 3. If x is 0, we see y, okay, we want to graph first y equals 2x minus 3. If we set x equal to 0, y equals to -3, so we get 1 point. 0, -3, get this point. Right? If we set x equals to 1, we get a y equals to 2 minus 3, -1. So 1 comma -1, we get this point. Now with this, we can graph. Also, we graph dotted line because there's no equal sign, only less than sign. So you graph with dotted line. Okay. But the sign is well less than. So less than, we will shade it below the line. All those points, the x value, y value of all those points will satisfy this inequality. Two-dimension solutions. Okay, now let's see 7. 7 is the last one. So 7, system of inequalities. Remember, just like lines, right? We put two lines together, we call system of two linear equations. So when we put the two inequalities together, we call system of inequalities. So which means we want to find, so this is like an and. So this is like an and case. Remember, we have an and or. This is like an and case for both of them. So we need to graph the solution for the first one. Then we graph the solution for the second one. Then we see the two solution sets. Where do the two solution sets overlapping? So let's see the first one. First one, if x equals 0, we get a y equals -3, right? If x equals 1, we get a y equals -2. Where x is 0, you see -3. Because we want to graph y equals to x minus 3. So we need 2 points. Now 0, -3, and 1, -2. No equal signs, we'll graph dotted line. And the y greater than, above the line, all those points are in the solution set. Now let's use blue color. The second one, if x equals 0, we see y equals 2, get this point. If x equals 1, get -1, because -3 plus 2, -1. Right? So 0, 2 here, 1, -1, 1, -1, somewhere here. No equal sign, graph dotted line. So that's this one. Then this is y less than. So less than, we need to graph below the line. So which is this. All those points are in the solution set. Where do they overlap? We see this area, right? So we can write S here. You see the grades? right? With this grid, that means it's a solution for the first one, for the red, and also a solution for the blue. Okay, similarly for this one, first we want to move x to the other side, becomes minus x. We want to move this one to the other side, becomes minus x. Now this one, let's divide by, we don't really have to divide by 2 if it's positive. If it's positive number, we can leave it. Let's graph the first one. If x equals 0, we see y equals to 4, get 1 point. If x equals to 1, 4 minus 1, which is 3, get 7 point. So 1 comma 3, this point, 0 comma 4, this point. Okay. Then we can graph. Well, this one we're going to graph with solid because this is less than or equal to. So grid will graph a solid line. Then we see y is less than or equal to 4. So down below. Okay. Of course, this keeps going. So all those down below that line. All those are solutions. Okay. Even those guys are off the chart. Second one, let's use red color. The second one, we have 2y, we have this one, right? If x is 0, we have 2y greater than 2, so y is 1. If x is 2, 2 minus 2 is 0. 0 divided by 2 is 0. So 0 comma 1, this point. 2 comma 0, have this point. Also with the equal sign, so graph with solid line. Okay. And this is greater than or equal to, that's above the line. All those are in the solution set. Where do those solution sets intersect or overlapping? We see right here, right? Inside those two lines. And that's it. And yeah, hopefully you have time to preview. Then we'll talk about it in class this afternoon. This.